All right, if you guys can turn to page 14. Okay, I feel like a lot of this will feel familiar from before. We're going to just be involving these log properties, but we're kind of just building off of it. Oh, we're just kind of building off of last week's work, so we'll take it slowly through these 2 pages. So today we're working on page 14 and 15. And then the next few days, we're just going to be cycling through the same thing. So we're going to get really comfortable with this topic. We're going to see it in calculus if you take it next year as well. So the more comfortable we are here, I think it's going to really benefit next year. All right, let me read through the notes here. The opposite of taking the log of both sides is to take the exponentiate of both sides. So whatever we do to one side, we can do to the other. We can use logs to cancel out exponentials. We can use exponentials to cancel out logs because they're inverses of each other. We really want to take advantage of the inverse functions to help us clean up the equation and get to the variable we're looking for. Okay, this can be used to cancel a logarithm from one side or more sides of an equation. To do this, make each side of the equation the exponent of the value of the base of the log. I'll show you as we go through these problems. This may have the effect of converting a log into an exponential form. Also, the argument of a log must be positive. So I can't have a log of a negative value. So for instance, if I have log base 2 of negative 24, okay, this just doesn't work. Okay, log of negative is not going to be a real number. Right? Check for extraneous solutions, meaning if the value you get for x makes an argument either 0 or a negative, an argument is basically in this slot. It's not the base, but it's the value inside the log. You must exclude that value from the solution set. All right, so number 1, -3 natural log of x equals -24. It's always good to, if we don't see the base, it's always good to put it in the expanded form. But first things first, let's just see if we can get this natural log of x by itself. What can we do to both sides? Yeah, divide by -3. Okay. Okay, natural log of x equals 8. And if I see a log or a natural log, I always want to, especially when I'm solving, I always want to put it in the expanded form that I can see the base a little bit easier and I can kind of go through that process of converting a little easier. So natural log is the same thing as log base e of x. And we always want to try to take advantage of exponential form if we're in logs, and usually if we're in logs or if we're in exponential, we want to get it back into logs. In this case, the x is stuck inside the log function. If we want to kind of free it from that form, we can get it into exponential form. So remember, we kind of go in a circle, right, as we go through the process. We can start with e. E raised to the 8th is equal to x. And that's a pretty large number, but this is an exact value, so we can leave it in that form. X is e to the 8th. Remember, e is a number, so it's around 2.7. That's just 2.7 to the 8th power. All right, same idea with this. We're just going to try and find a way to get the 16, the 3, and the 4 to be together, and then we can work with this log once we get this by itself. Okay, so what can we do first? Yeah, let's deal with the 4. Okay, next. Yeah. This is in the shorthand form. What's the hidden base here? 10. Okay. So once you get that 10, it's a little bit easier now to kind of convert it into exponential form, right? We start with the base. Base raised to the exponent is equal to the value, right? Just go in a circle and pick up values as you go along. Okay. 10 to the negative 4 equals 5x. Let me just put this 5x on the left side. What's another way of saying 10 to the negative 4? 1, what? Yeah, 1 over 10 to the 4th. Okay, so anytime you have a negative exponent, you can always take the base and flip it to the other side. Okay. So this is basically 1 over 10,000, right? And then we divide by 5, which is the same thing as multiplying by 1/5. Okay, number 3. Log base 3 of x minus 1 equals negative 2. Remember, this is an argument here. We can't distribute this log through. Okay, this is not one of the properties available to us. Okay, so the best we can do is we can't do anything in this form. So let's get into exponential form. What would exponential form look like for this log function?
3.
Mm-hmm. Well, how do we get this into exponential form? 3 raised to the, yeah, equals x minus 1, right? So just go in a circle and pick up values along the way. What's another way of cleaning up 3 to the negative 2? 1 over 3 squared, which is 1/9. Okay, add 1 to both sides. 1/9 plus 1 is the same thing as 1/9 plus 9 over 9, which is 10 over 9. I want to show you different ways of converting into exponential form. It really doesn't matter which way you choose. It's just if I give you a bunch of different options, then you can see things from different perspectives. So another way that you can always go through this process of going in around a circle, picking up values, and converting it into exponential form. But here's another way that you can do it: is if I have log base 3 of x minus 1 equals negative 2. Remember how we can take the log of both sides to get rid of an exponential form? Same thing here. I can raise both sides with the same base. That'll work as well. So if I raise everything up as base 3, the property that's occurring here is 3 to the log base 3 is this property. B to the log base B. This basically does the work of canceling out because you have a log in the exponential of the same base. And if this cancels out, this drops down, and I'm left with x minus 1 equals 3 to the negative 2. So you can either go through this process of picking up values from one form to the next, or you can raise both sides to the base that matches the log function, and that will also allow things to work out the same way. Okay. All right, number 4.
So those are 2 different ways.
Right, just two different ways of visualizing converting from log form to exponential form. I'm not going to require you to do one over the other. it's just two different ways to see things. Okay, number four. Number four, the nice thing here is that they both share log base 2. So we can just basically make them cancel out. Or in other words, we're really raising both sides with 2 as the base. And that's going to do the work of eliminating that base, and we can solve for just the argument. Okay, add 4 to both sides. Okay, whenever we get a negative number, it's always good to double check and make sure that it's not going to cause the argument to be negative. If it caused the argument to be negative, we have to eliminate it as a invalid or excluded value. So if I plug negative 5 in for x, I get negative 5 squared, which is 25 minus 4. That's okay. That's positive. And 5 squared minus 4 is also positive. So we're good there. Okay, let's go down to number 5 here. You may have to use properties to change the equation to have at most one logarithm on each side of the equation. Okay, so number 5, we see that I have log base 7, so that's good. I can almost take it out, but there is something that's getting in the way here, is this 3. So is there a better place to put the 3 so we can have log base 7 equals log base 7? Any ideas? Yeah. Say it again. Yeah, exponent as what? X to the third. Okay, so we can't divide it to the other side because this 3 and this 64 are not in the same places, right? The 64 is inside the log. We can't divide that, but we can put this 3 up as the exponent. And when we do that, we're able to get apples to apples with these log expressions. And now we can remove it. Okay, if we remove it beforehand, we're not quite having matching logs, but now we have log base 7 equals log base 7. That 3 has been dealt with. You can think of it as raising both sides with 7 as a base, or you're just basically taking that log base 7 away from both sides. X cubed equals 64. Okay. Take the cube root of both sides. Okay. Number 6. Can I start canceling the log base 2's out? Okay. Eventually, okay, but not yet. Yeah, we have to find a way to do it with these 2 logs. Yeah, we have to merge them together. Okay. I need this to be log base 2 equals log base 2. I can't have log base 2 equals log base 2 minus another log base 2. I need these to come together. So which property do we have available to combine these 2 logs together? Quotient. Yeah, so on the board there, quotient property. All right, if I have log of u minus log of v, I can merge them together to be log of u over v. So I can take the 10 and the x minus 4 and put them over each other. Now that I have log base 2 equals log base 2, we can make them or raise both sides with 2 as the base. Everything go away. Now we can just solve for x. Okay, I'll put that 5, make it 5 over 1. And I can just cross multiply and solve for x. Right? Whenever I see a fraction equal to a fraction, I find that's the easiest way to get the denominators out of the way. Okay, cross multiply. Double check 6 in for the arguments is not going to cause an issue, right? 6 minus 4 is 2, and there's no variables here, so we're okay. All right, we got to have 1 log equal to 1 log before we can cancel out. If we have log separate by plus or minus, we got to find a way to merge them together first. Okay, number 7. Everything is log base 4, so we know eventually we're going to be able to get log base 4 to cancel out, but not yet. Right? What could we do first? Product property, right? I can merge these two logs together, right? Log of u plus log of v equals log of u times v. So this is my u, that's my v. I'll merge them together. Log base 4, log base 4. I can take this out and FOIL everything out and see if I can find a way to solve for x. Like, what if I just bring everything over to one side and try to solve for x that way? This is factorable. Multiplies to be 15, adds it to be -8. All right, we got to be careful here because we have to make sure that we don't have any extraneous solutions. So let's enter 5 in. We just want to check to see if 5 is going to cause any of these arguments to be either 0 or negative, right? We can't have 0 or negative values here. So 5 minus 3 is okay. 5 plus 1 is okay. 5 times 6 is 30. 30 minus 18, that's okay. If I plug 3 in, 3 minus 3 is 0. 6 times 3 minus 18 is also 0. We can't have log of 0. So that's set to be removed. Okay. Now, if it causes any argument to give you a value that's undefined, that doesn't work, then we have to remove it. Okay. It's not that it has to fail every one. If it fails even one of them, we have to remove it. So 3 is not going to work. Only 5 is our solution. All right. Natural log equals 1 plus natural log of 2x plus 3. We really can't find a way to merge these together. I can't cancel the natural logs out. That 1 is kind of getting in the way. So what if I rearranged it to try to get the natural logs to merge together? Okay. So now I can take advantage of quotient property. If I'm subtracting 2 logs, I can write it as a log of u over v, quotient property. Okay, so to see things a little bit more clearly, what can I do with natural log? Make it what? Rewrite it as, yeah, log base e, so we can kind of see what the base is and how to maybe convert it into a different form that makes it easier to work with. So I think exponential form will be easier, right? I can raise both sides with e as the base, or I can go through this process. E to the first power is equal to the parentheses. All right, it's a little messy here. I'm going to have to put this e over 1. Let me cross multiply. Merge the x's together. Factor out the x. Okay, so maybe easiest to just use our calculator. I'll put that in for us, just so I can quickly plug in and see if it's actually going to cause any of the arguments to go to 0 or to be a negative value. Got negative 4.98. So if I do 3 times negative 5, negative 15 minus 4 is negative. Okay, it's going to, as long as it makes one argument produce a negative value, that's enough to know that it's not a solution that I can use. Okay, so our classwork is page 15, and I'll be working through this the same time you guys are, so you can check your answers as you work through. Okay. All right, does anybody still need this page? Okay. Okay, everybody good? Yeah. Yeah.
It's open.
Work it to 8, you divide out the,
Yeah,
you divide out the 8, but what makes it different from the 3 there? Like, they're both in the same spot, but what makes this 3
Right.
different?
So the thing is, you see this is log, the 64 is inside the log, so I can't divide the 3 over. The 3 is outside the log. Here,
Oh, there's no.
yeah,
because there's
this
no
one,
log.
that's right, the 8 and the 64 are, they're clear. They can work with each
Okay,
other.
okay,
Yeah.
that makes sense. Thank you.
Any questions with 1 through 3? Can I move 1 through 3 up? Does anybody still need 1 through 3? Okay. Okay. Everybody good? 1 through 3? Everybody good with 4? Because there's no taking the square root. So whenever we take the square root of both sides of the equation, a plus or minus will show up. reminder about factoring here. I think a lot of students are tempted to factor in that form. We can't take the GCF out. Set it to 18 and set x equal to 18 and x plus 7 equals 18. It doesn't work that way. We got to have everything equal to 0 before you can look for factors. You can't do it this way. This is not, it feels easier, but it's not going to get us the right answer. All right, is everybody good with 7 and 8?
Okay.
Yeah.
It was a good extraneous, but it's been
If we insert 13/6 in for any of the x's, we're still going to be safe with positive numbers.
oh, okay.
So as long as it doesn't cause any parentheses to go to 0 or negative, we can keep it. Okay. Everybody good with 9? Here's 10. There's something to watch out for with number 10 that we haven't seen before. And that's the fact that before you can merge these two logs together, what has to first be dealt with? Yeah, this 2 is not in the right place for these two to connect yet. So this 2 has to come up. When it comes up, it's going to influence that entire 3x squared. So it's going to be 3x squared squared. And then once you have a clean log minus log with no coefficient in front, then you can do quotient property.
You don't distribute it straight into the exponent of 2, you have to do the whole x squared.
Yeah, it's not just because the 3x squared is the entire log expression, or it's the entire argument. So when the 2 comes up, it has to influence the entire. So that's a little bit tricky for number 10. Okay, so we're good with 10. Good. All right, let me show 11. Okay, I'm gonna have you guys finish up 11 and 12, and then I'll check the classwork tomorrow, but I'm not gonna have enough time, but gonna have you guys see if you can work through 12 as well. 12 is same thing as 11. You get the logs together so that you can use either product or quotient, and then get into exponential form and then solve for x. Remember that anytime we solve for x, we got to insert this solution into all the arguments that has variables and check to see if it causes any argument to be negative or 0. If it causes any argument to be 0 or negative, we have to remove it. It's not part of our solution set. All right, are we good with 11? Guys, tomorrow, Wednesday, Thursday, nothing new. We're just going to practice through these problems, get really comfortable with them. Okay, so we've covered all the new material up until Thursday. We're just going to practice this, and then we'll cover graphing Friday and Monday. And then Tuesday, Wednesday, test review, and Thursday test. Okay, I'll check these pages tomorrow. Yeah, yeah.
Definitely.